Hello friends, welcome to Blessed Excellence Center. Do it to subscribe to our channel. In our last class, we looked at introductory aspect of de novo synthesis. Today, we're going to continue from there by giving attention to some terminologies that will enable you guys to understand the concept of de novo synthesis of purine nucleotides. And the first concept you're going to consider is a reaction I called pyrophosphorylation reaction. Pyrophosphorylation reaction. Okay, good. What does it mean? This is a biochemical reaction involving the addition of pyrophosphate group PPI to a substrate. Recall that two inorganic phosphates Pi is known as pyrophosphates. The reaction is driven by pyrophosphokinases and utilizes ATP while releasing AMP and Pi. So you can see this reaction now. When you have, for example, now you have oxygen here, you have phosphate group, you have oxygen, you have oxygen, you have oxygen. There are two phosphate group here. These two phosphate group linked together is what we call pyrophosphates. So the type of reaction that involves the addition of this pyrophosphate to a substance is called pyrophosphorylation reaction. Okay, good. Now the source of this pyrophosphates is ATP. Remember, ATP is adenosine triphosphate. That means it has three phosphate group. So if two of the phosphate group is pulled out, what is left is one, and that is what we have here as AMP, which is adenosine monophosphates. And then that the two phosphate group that is pulled out is now added here, and that is what you see happening here. You see, when you have one phosphate group, we call this ribose 5 phosphates. This ribose sugar, this phosphate group, and it's attached to carbon 5. Carbon 1, carbon 2, carbon 3, carbon 4, and carbon 5. So we call this ribose 5 phosphates. So a reaction involving the addition of pyrophosphate group to these components is what we call pyrophosphorylation reaction. It is actually the preliminary step of purine de novo synthesis, which we are going to talk more when we consider the pathway proper. But for now, I just want you to understand that two phosphate group pulls out from this ATP and is attached here to give you this guy you are seeing here. And we call this phosphoribosyl 1 pyrophosphates. Phosphoribosyl 1 pyrophosphate. So that is the first reaction we're going to consider. I want to understand it. The enzyme that drives the reaction is called ribose 1-phosphate pyrophosphokinases. Remember that kinases are enzymes that add phosphate group to a substance, and since they are adding pyrophosphate group, they are called pyrophosphokinases. Okay, good. So the next terminology we are going to look at is formulation reaction. What is formulation reaction? This reaction is associated with the addition of formyl group. Formyl group is CHO. That is formyl group, that's aldehyde. The addition of formyl group to a substance. The substance here could be a metabolite or an intermediate. Okay, good. Now, formyl group in this case is aldehyde functional group. The reaction is catalyzed by transformylase, which can also be called formyl transferase. There is another name for transformylase is formyl transferase. And then N5N10 methylene tetrahydrofolates is the source of the formyl group, and when it donates the formyl group, it becomes tetrahydrofolate after the reaction. Okay, good. Now look at the mechanism of the reaction here. But before talking of the mechanism, I want you to understand something, that when you say addition of something, the stuff to be added must come from somewhere. Okay, so when you are adding formyl group to a substance, the formyl group must come from somewhere. So the source of the formyl group is what we call N5N10 tetrahydrofolates, and then when N5N10 tetrahydrofolate donates the formyl group, it becomes tetrahydrofolate. Okay, good. Now look at this reaction. Forget about the bulky nature of this reaction. By the time I start teaching you on the steps involved in de novo synthesis, you will understand the structure better. But for now, I want to pay a closer attention to this carbon bonding oxygen and hydrogen, this component in blue. That is where our emphasis is. If you observe very well, here we have only NH2. There is no this component in this here, in this group, in this place. Okay, but here is attached. So what happens here is that the formyl group has been added to these components to give you this you are seeing here, and a reaction involving the addition of this component, this formyl group, is what we call transformylation reaction. It's called formulation reaction. Okay, good. And the enzyme that drives the reaction is called transformylase. You can see the enzyme here. E is the enzyme of the reaction, and it's called Ca transformylase. It's called Ga transformylase because the substrate, the starting component is already Ga. Okay, so we call it Ga, which is glycinamide ribonucleotide. So it is glycinamide ribonucleotide transformylase. The point of emphasis here, now what we want to understand at this point is that the addition of C double bond O and H to this to give you this is what we refer to as transformylation reaction. All right, so the next concept we are going to consider is carboxylation reaction. What is carboxylation reaction? This is a reaction that has to do with the addition of carbon 4 oxide to a metabolite. The carboxylases drive the reaction. So what that means is that a reaction that involves the addition of carbon 4 oxide to a substance is called carboxylation reaction. And as a biochemist, you're expected to know the enzyme that drives the reaction. So the enzyme that drives carboxylation reaction is called carboxylase. Okay, good. Look at the reaction here. You can see the inculcation of carbon 4 oxide, and it requires ATP. I keep telling you, don't bother yourself about the bulky nature of the reaction. I'm going to detail, I'm going to start from the scratch to explain all this structure so that you understand it better. But for now, I want to understand what we call carboxylation, that involves the addition of carbon dioxide to a substance. So if you see this structure here, this structure and this structure are just almost the same thing. The only point of difference is the addition of this carbon dioxide here. So it is this carbon dioxide that is added here to give you this compound you are seeing here. So such a reaction is what we call carboxylation reaction. So these are the important terminologies you need to understand. And by the time you understand it, when we go to the synthesis proper, you're not going to find it difficult. Thanks for watching. Do it to subscribe to our channel. If you've not yet subscribed, then like the video, click on the bell so they can have our latest video, then drop your comment.